Yes, good morning. So in this, we are going to discuss about the properties of colloids. Okay, the properties which are possessed by colloidal solutions, okay, or colloidal particles that we are going to discuss in this. Okay, very important part. So first of all, that is Tyndall effect. Tyndall effect we have also discussed. You might have studied in previous classes that what is Tyndall effect. Tyndall effect is this scattering of light. Okay, scattering of light by the colloidal particles, that is called as Tyndall effect. That is scattering of light by colloidal particles. Now this Tyndall effect, it was on the very first note, it was given by Faraday. Faraday was the first scientist who observed Tyndall effect. Okay, now there are two conditions for this Tyndall effect to be enforced. Okay, there are two conditions. Now, what are those two conditions? Only if those two conditions they will be fulfilled, only then this Tyndall effect that will be observed. So first of all, the condition is that diameter of dispersed particle that must not be much smaller than the wavelength of light used. Okay, that is diameter of dispersed particles not much smaller than wavelength of light used. This is a very important requirement for this Tyndall effect. Okay, means that the diameter and the wavelength of light, they must be having approximate values, they must be having approximate same values, they must not differ much, and they must not be having a lot of difference in their values. Okay, they must be almost equal or near to each other. Along with that, second condition is that refractive index of dispersed phase and dispersed medium that must differ in great extent in the magnitude. That is, magnitude of dispersed phase and dispersed medium must differ greatly. Okay, means that they must be having a lot of difference, they must differ greatly. Okay, their magnitude must be very much different. So these are the two conditions which are required for the Tyndall effect to be observed in the colloidal solutions. Okay, that is scattering of light by colloidal particles. Okay, and on the very first note, it was observed by the Faraday. Okay. Now, second condition, now second property which is shown by the colloidal solutions, that is the color. See, color which is shown by the colloidal particles, that depends upon the light, wavelength of the light which is scattered by the dispersed particles. Okay, color that depends upon wavelength of light dispersed by particles. Okay, or scattered by particles. So this is the second condition, second property, that color they will be showing in accordance with the wavelength of light that they are dispersing or scattering. Next, third is the Brownian movement. Now, what is this Brownian movement? See, Brownian movement means that these colloidal particles, when observed under microscope, they showed zigzag movements, they showed very random movements. Okay, they show this zigzag movements, and this property of showing these different zigzag movements, okay, something like this, means that movement is happening in the straight line. Okay, there are no curves, that is happening as zigzag movements. So those zigzag movement, that is called as Brownian movement, which is shown by the colloidal particles. Zigzag movement of colloidal particles. So this is the third property. Now, next property, that is electrophoresis. Now, electrophoresis, it is also a very important property. What is electrophoresis? See, the colloidal particles, they always carry some charge. Okay, colloidal particles always carry some charge. Now, when electric field is applied on these colloidal solutions or these colloidal particles, then they will move, okay, with respect to the anode and cathode. It means that colloidal particles, they are carrying some charge, and when electric field is applied, these particles, they will show movements. That property, that showing of those movements by these colloidal particles under that applied electric field is called as electrophoresis. Okay, what will happen under electric field? These particles start moving and they show movements, that is called as electrophoresis. Okay, now when this electric field is applied, then this positive charge, it will move towards the cathode. It will start moving towards cathode, and negative charge, it will move towards the anode. Okay, under this applied electric field, this positive charge will move towards cathode and negative charge will move towards the anode. Okay. Now, next property is the coagulation. What is coagulation? Coagulation is settling of colloidal particles. Okay. For example, we have in a jar, we have this colloidal solution. Okay, and these colloidal particles, they move at the bottom, they settle at the bottom. Okay, the particles of the dispersed phase, when they settle at the bottom, that property of settling at bottom is called as the coagulation. Okay, settling of colloidal particles is called as coagulation, and it is also called as precipitation. Okay, now it can be carried out by addition of electrolytes. When electrolytes, they are added, how coagulation is done? For that, we require something, we require an external force. So by adding an electrolyte, we can complete this process of coagulation. Okay, and the ion which is there in these electrolytes, which is added for this process of coagulation to happen, that ion is called as coagulating ion. Okay, that ion is called as coagulating ion. Now, greater the charge of coagulating ion, okay, greater is the charge on the coagulating ion, better is its coagulating or flocculating power. For example, I have this Al3 positive, Ba2 positive, and Na positive. Now, aluminium has 3 positive charge, barium has 2 positive, and sodium has 1 positive charge. So aluminium is having higher charge, greater charge. So that's why it is having better flocculating power. Okay, it is having higher flocculating power, and these positive charges, they will be used for coagulation of which ions? That is negative charge. Okay, for example, this is the power which I have written used for the coagulation of negative charge. That is Al3 positive, positive used for coagulating negative ones. So higher the charge, so better is the flocculating power, Al3 positive, Ba2 positive, and Na positive. Okay.